this recording. Okay, have you done these?
A little bit.
Okay, so let's see, do we want to begin any particular spot? Are you comfortable with A and B?
Yeah, I think.
That you got those right? You've substituted 1 minus y for x and then solved. Looks like that's correct. And then after you solved for y, you went back, substituted it, and came up with x. Okay, that looks right. I'll assume this one is right. That one's right. About B.
Do you multiply the top numbers?
Whenever you are multiplying the base, you add the exponents. In other words, if I have a common base to some exponent, and I'm multiplying it by another common base to a different exponent, I'm going to do to the exponents one level less than I'm doing to the problem. The problem is multiplication, so I'm going to add the exponents. If I am dividing, same base, different exponents, I'm going to subtract the exponents, one level less. And if I am exponentiating, I'm going to do one level less, which is multiplication.
Okay.
See the pattern?
Yeah.
Okay, so what's the numerator going to be?
P to the 60th?
No, we're multiplying, so what are we going to do to the exponents?
Add.
So what's 5 plus 4 plus 3?
9, 12.
So that's the numerator. And what about the denominator?
P to the third.
And now we're going to divide, same base, different exponents. So what's this whole thing equal to?
P to the fourth.
Subtract the exponents, don't divide them. Remember, you do different to the exponents than is being done to the base.
P to the negative 9.
It's never the same. P to the positive 9. It's 12 minus 3. It's just like that.
Okay.
Okay? What would that be equal to?
P to the second.
Well, there's no P.
Oh. 2 to the second.
Yeah. Equals 4. And notice how much easier it is to do this way rather than having to figure out what 2 to the 7th is. 2 to the 7th must be like 256 divided by 32. Now this must be 128 for that to be 4. But in other words, you can see the value in having this little shortcut. Being able to subtract the exponents gets us to the solution without dealing with a number bigger than 7. Okay. What's the first job here?
Multiply.
Well,
no, add.
you want to get rid of the exponent or the parentheses, or both. Okay? In other words, the fact that all of this is inside the parentheses and the whole thing is being squared, I have to apply this 2 to every term in there. I have to square it. So to get rid of the parentheses, I'm going to leave the 4x on the bottom for the moment, but let's figure out the new numerator.
3x to the 4th.
Okay, do it term at a time. Square the number, and then square the x variable, and then square the y variable. So what is 3 squared?
6.
3 squared.
No, 9.
Okay, so there's the number part. What is x squared squared again?
X to the 4th.
And what is the rest of it?
Y squared.
Okay. Now we can simplify that because we have an x in the denominator and an x in the numerator. So let's simplify that. What's x to the 4th over x equal to?
I don't know.
What's the exponent on this lower half x?
1.
Now what's it equal to?
X to the 4th.
We're dividing. What are we going to do with the exponents?
Subtract.
Yep.
So x to the 3rd.
Right. Okay, so that we have up here x to the 4th divided by x. So this becomes 9x cubed y squared over 4.
Okay.
In other words, I took this part of it and changed it to x to the cubed.
Okay.
Okay? Let's see what else we got here. Oh, that's nice. They came up with a similar problem that I came up with. Powers of 2. Hold on. So 2 to the 5th times 2 to the 9th. In other words, there's no dot, there's no parentheses, but it's still multiplication taking place.
Okay, 2 to the 45th.
We're going to do one level. Always remember this, Julian. You're never going to do the same thing to the exponents that you're doing to the base.
Okay.
We're multiplying the bases, right?
Yeah.
So we're not going to multiply the exponents. What are we going to do? What are we going to do, Tom?
Add them.
Okay. What's that equal to?
5 to the negative 3rd.
Yep. Okay. Now what's going on here? What are we doing here in this problem here? What's it called? It's not multiplication, it's not division.
I don't know, addition?
Called exponentiation.
Okay.
What do we do to the exponents when we're doing exponentiation?
I don't know.
Multiply.
Okay.
This is where we multiply the exponents. We're not doing multiplication in the problem, but exponentiation is one level higher than multiplication. So this is going to be equal to what?
7 to the 60th.
Uh-huh. Okay. About
Is it 8 to the negative 7th?
It is, except for one problem. The instructions say final answers should contain no negative exponents. So how do I write that without a negative exponent?
1 over 8 to the 7th?
Yeah. Okay. Hold on. Let's see. Let me get, I can move this a little bit better. One second. Okay. This looks familiar. We didn't do this last week?
I don't think so.
Okay. I must have another student that has these same problems.
Really?
Yeah, I must have, because I've done this problem recently. I think I've done all three of these recently. So how do I write this in scientific notation?
1.213?
Are those the same numbers?
No.
What's the rest of it?
I don't know.
Scientific notation is always times 10 to some power. And the power is the number of places I have to move to get that decimal point from here where it started. I got to move it 3 places to the left to turn it into that number. So it's times 10 to the third.
Okay.
These two are equal. In other words, this is 1.213. Well, what's 10 to the third? It's 1,000. So if I multiply 1.213 times 1,000, I get that number. Okay? Okay. That's the same process we're going to do on all of these. We got 1, 2, 9 zeros. So what's the first part of it?
0.0?
No. In scientific notation, the first part of it always has to be a number between 1 and 10.
Oh. So between the 5 and the 7?
Yeah. So the first number is going to be 5.7 because that's between 1 and 10. Well, and it's going to be times 10 to some exponent. Only in this case, I got to move the decimal place to the right, not the left. So my exponent is going to be a minus however many places I need to move it. Well, I need to move it 3, 6, 9, 10.
Okay.
Minus 10. Okay? You got the strategy down?
Yeah.
Okay, what's the next one?
Is it between the 1 and the 2?
Okay. So what's the answer?
1.2895713.
Times?
To the 6th power? Times 10 to the 6th?
How many spots do I have to move that decimal point to get it to where it is?
Oh, 4?
Uh-huh. That's how you do it. If you have to move the decimal point to the left, it's a positive 4. If you have to move it to the right, like we did in this one, it's a negative, however many times spots you have to move it. Okay?
Okay.
All right, let's see. Simplify and then write the answer in scientific notation. Okay, we got 12.7 times 10 to the 5th that we're going to multiply by 0.2 times 10 to the 6th. Well, these are pretty easy to multiply, actually. You multiply the number part, and then you multiply the 10 to the 5th times 10 to the 6th part.
Okay.
So what do we get when we multiply the number part? Do you have a calculator?
Yeah.
Let's go ahead and multiply that on your calculator.
104.14.
So 104.14, and what's the rest of it? Times 10 to the what?
10 to the 11.
Uh-huh. Now we need to put this in scientific notation. It's not in scientific notation at the moment because this number is not between 1 and 10.
Okay. You put it between the 1 and the 0.
Okay. So what's the answer?
1.0414 times x to the 11th.
Times 10 to the what?
Oh, 10 to the 11th.
Not anymore. It's a different number.
Oh,
It was 10 to the 11th.
the second?
Now, how many spots do I have to move that decimal point? 2 is correct, but I have to add that 2 to the 11th.
Oh, to the 13th.
Yeah. And if I was going the other way, I would subtract it from the 11.
Yeah.
Always remember that these numbers have to make sense. In other words, when you said 2, that can't be because 10 to the 2nd is 100. If I multiply this number by 100, I get this number right here. Well, that's not our number. Our number was that times 10 to the 11th, which is a gigantic trillion.
Yeah.
So always make sure when you're doing math problems that your numbers make sense. It's called doing what I call the ballpark check. This does not pass the ballpark check because of that 2.
Okay.
13 does. Okay. This one, use your calculator to first find out the number, and then we'll put it in scientific notation.
Okay. So, do I divide or subtract?
Well, at the moment, we're doing the number part. We're just doing this part here. So that's division.
Okay. 0.059259
0.05, what's the rest of it?
0.0759 2593
Times 10 to the what?
Um,
Now we're dividing 10 to the 7th by 10 to the 12th. That's same base, different exponents.
is it 10 to the negative 5th?
Good. So now we have to take this number and turn it into scientific notation. The number we have is, tell me if I wrote this down right.
Yeah.
Okay. So let's turn that into scientific notation. So what's the first part going to be?
Put the decimal between the 0 and the 7.
No. Remember, the number's got to be between 1 and 10.
Oh,
If I were to put the number right there, it would be 0.7. So it wouldn't be, it would be less than 1.
between the 7 and the 5?
Okay. So 7.592593 times 10 to the what?
10 to the negative fourth.
How many places did we have to move the decimal point?
Just one. No, two, I think.
2. And we moved it to the right.
Oh, so 10 to the negative seventh.
There you go. In other words, we have to subtract 2 from this one because we moved it 2 spots to the right. Remember, if you move to the left, you add. If you move to the right, you subtract. Okay. Well, that covers your worksheet. You got any more worksheet? Another sheet?
No, that's the only one.
That's the only one?
Yeah.
All right. Well, let's spend a little bit of time then doing this other, if that's okay.
Okay.
I want you to get better and faster every week here.
Okay.
What's this? It's 27 divided by 9?
3.
As fast as you can.
6. 2. 4. 3.
Excuse me.
4. Bless you.
If I put 4 in there, look what happens.
6.
Okay? In other words, that last one was 3.
Okay.
Okay?
5. 6.
Okay, to check your answer whether 6 is correct, multiply 2 times 6.
No, I think it's 9.
There you go. 2 times 9 is 18.
Yeah. 2. 6. 2. 9. 6. 9.
You know your 9s really well, I think.
Yeah. 4? Wait.
Yeah, no, that was correct.
Yeah. Okay.
This one usually gives people little problems.
7?
What's 7 times 7?
Oh, 49. 8.
Okay. That's the way you want to do it, is always multiply. Let's see. Hold on, let's go to a multiplication. You know, they added one here. Gosh, I hope this is what I think it is. I cannot find flashcards that do this right. What's this?
95. 95.
Yeah. Oh, let's back up. Gosh, I don't know why nobody puts the proper things in their digital flashcards. Let me make some up on what I want to test you on, which is adding and subtracting negative numbers and positive numbers. So I'll just write some down here.
-3. -1.
No.
This
is the one that people have the most difficulty with, is when you have a negative number subtracting a positive number.
Oh, -7?
Yeah, notice the two dashes here don't mean the same thing. That means negative attached to the 3.
Yeah.
This means subtraction. So how do we do all subtraction problems? If there's any difficulty at all, we turn them into addition problems.
Okay.
Do that, and then we change the sign on the number that was being subtracted. So now it becomes -3 plus a -4. Well, most people know that is -7. So it's the easiest way to do subtraction is by turning it into addition. Same way that we do division. If I say do that, well, you go ahead and do division to come up with that. But if I say, what is 8 divided by 1/2, generally you don't do division. You flip the denominator and do multiplication. In other words, that's the same as 8 times 2 over 1, which would be 16. So in the same way that you never do division when it's a fraction, you turn it into a multiplication problem, well, every time we have a subtraction problem, we're going to turn it into a addition problem. Even that.
Okay.
Well, how do I do that? Well, I make it plus a -6. Well, if I said, what is 7 plus a -6, what is it?
1.
Right. Which means that I really didn't need to do it. I knew how to do subtraction as long as I have a bigger number minus a smaller number. It's just like I know how to do division as long as I'm dividing by a whole number. But when the problem becomes more complicated, you want to turn it into an addition problem, and that always will clarify it.
Okay.
Okay? Now, it's also not hard to subtract a positive number from another positive number. You know how to do that.
Yeah.
The only one you seem to have problems with is when you take a negative number and subtract a positive number. What's that? Turn it into an addition problem.
-12?
Yeah. In other words, after I've turned it into an addition problem, it becomes this.
Yeah.
That's -12. All right. Let's see. Let's see if they have any good subtraction problems. See how fast you are here.
-1?
Is it -1?
Yeah.
9 minus 8?
Oh, 1. 2. 5. 16. 6. 6. 3.
Okay, we need to get your speed up a little bit.
6.
6 plus 6, 12 or 18?
Oh no. 12. 1.
These are all going to be positive numbers. In other words, they don't have what I would like to see on this, which is positive and negative numbers and negative answers.
Yeah, 1. It's 5. 4. 0. 3. 13. 10. 4.
Okay, let's do a little multiplication.
Okay. Um, 21. 15. 38.
Good. I was going to say, try to do this almost in your head.
48. 90. 24. 40. 40.
Wow, that's weird. Now, when I multiply in my head, I do it left to right. I don't do it right to left like they teach you. In other words, when I'm multiplying 4 times 16, I'm going to do the 4 times the 10 first.
Yeah.
That's 40. Then I'm going to add to that 4 times 6, which is 24. So it's 40 plus 24, 64.
Okay.
You can do that process entirely in your head.
Yeah.
As opposed to doing 4 times 6 is 4, carry the 2, 4 times 1 is 4, plus the 2 is 6. Notice the difference. In one case I'm doing it right to left, in the other case I'm doing it left to right. Well, if you're an engineer out in the field, the most important number to get right is this 6.
Yeah.
The least important number is the 4. That's why I do it left to right, not right to left, is because I'm more likely to get the more important digit correct by doing it the way I do it. Same thing here. I do the same thing. So what would this be?
96.
Good.
$48. 81.
You know your squares good?
66. 36. 60. 20. 56. 40. 22. 27. 76.
Good.
68.
Good.
12. 56. 56.
Yeah. Notice that 8 times 7 is 56, and 4 is half of 8, and 14 is twice 7.
Yeah.
So it's going to be the same number. All right. That's pretty good. It does feel to me like you've made quite a bit of progress with your multiplication, addition, subtraction, and division. And that's going to help you a lot. So let's see. I don't want to overdo it for you, though. You have any other problems at all from your homework to do? Or from your school, your classroom?
Let me check.
Okay. Actually, Julian,
Yeah?
I can make up some
Okay.
pretty easily. Let me make up some here.
X to the 6th.
Good. Is that equal to?
X to the negative 6th.
And without negative exponents?
1 over X to the 6th.
Good. What's that equal to?
12 X to the 6th.
Okay, hold on. This cubing exponent
Oh, yeah.
is what it is. So the first thing is 4 cubed.
Yeah,
We'll figure out what that is in a moment. We don't care yet. Let's write it like that. What's the next term? X to the 6th, that's correct.
and YZ to the...
Okay, y cubed,
Oh, okay.
and then z to the what?
Cubed. 3rd.
What are we doing here? What's it called?
Oh. Exponential something.
Exponentiation.
Okay.
What do you do to the exponents when you're doing exponentiation?
You multiply them?
Z to
So
the
Z
9.
to the 9. Okay.
Okay? And then 4 cubed is 64.
Okay.
Okay? What's this?
X to the 1st.
Trick question. You can't subtract different things. This is an apple, that is an orange. I cannot add or subtract them. So, in other words, that does not simplify. That's exactly what it is. X cubed minus x squared. It's easy to be fooled because your rules that we have only apply to multiplication, division, and exponentiation, those 3 things. There's no rules that apply to addition and subtraction. So if I was multiplying these two, what is
it? X to the 6th?
No.
Oh, X to the 5th?
Right. Remember, we never do the same thing with the exponents that we're doing to the base.
Yeah.
So it's never going to be multiplying the exponents if we're multiplying the base. We're only going to multiply the exponents if we're doing exponentiation. In other words, if exponentiation would be that, that would be x to the 6th.
Okay.
Why? Because that's the same as x cubed times x cubed. Add the exponents, you get x to the 6th. put this in scientific notation?
Point, wait, you put the decimal between the 0 and the 6?
No, that would leave a 0.6 as the first number. The first number's got to be
between the 6 and the 4?
10, yeah. So 6.4 times 10 to the what?
-7?
Good. Put that in scientific notation.
2.3. X to the,
That's not really x, that's times.
yeah, times. Okay,
that's
10.
Not a variable x, no.
10 to the 3rd?
No, there's a hidden 1 right there.
Okay.
So how many spots did I move my decimal point?
Just 1.
No, it was right there to begin with.
Oh. 3.
Yeah, it wasn't there. Right. Okay.
So is it 10 to the 4th?
Yes. This was also kind of a trick question because you're not likely to get something like this. But notice what that number is. That number is that. That's 23,720. When I said 2372 times 10 to the 1st, that's the same as 23,720, which is this number here also. In other words, when I multiply it by 10 to the 4th, I'm going to move the decimal point 4 spots.
Okay.
It becomes that number right there. Let's see, what else did you go over? Exponents, you got that down pretty good. Scientific notation, you got that down pretty good. What's that equal to?
Is it
Do it in two steps. Do that part. What's going on there?
9 minus 3?
Is it minus?
9 divided by 3?
Yeah. In other words, there's no minus sign there. Remember, this is the number part. There's no exponents involved here. So we have division going on, and that's it. So it's just 3. Now, to do this part, we've got exponents involved.
Yeah. Is it 10 to the 5th?
Yes. That's all you do, is you do it in 2 parts. You do the number part first, and then you do the power of 10 part next. Look at your sheet here again just quickly. No, I think you're pretty good to go on this, Julian. You feel comfortable with it?
Yeah.
I don't need to hold you for an hour just for the sake of holding you for an hour. Although you certainly, there's plenty of work that we have to do to get your math skills up there. But you've made pretty good progress.
Okay.
You feel like you're going to be able to do good on a quiz like this?
Yeah.
Now you have a quiz like this tomorrow?
Not tomorrow. I think next week.
Next week? Okay, but it's going to be on this material here?
Yeah.
Okay. Well, you really only need to memorize one thing or three things, and this, I can't emphasize how this is the best way to memorize it. That's number 1 for multiplication. This is number 2 for division.
Okay.
And this is number 3 for exponentiation. If you remember these 3, that'll take care of all your exponent problems. Just remember that you're going to do one level less. We're doing addition of the exponents when we do multiplication of the bases. When we do division of the bases, we're subtracting the exponents. When we do exponentiation, we're multiplying the exponents.
Okay.
All right. I guess we can call it a session if you don't have any more. Try to, or mention to your mother that wasn't really enough material for an hour.
All right. Okay.
Just if you have more material to send, it would be useful.
All right.
Okay. Okay. Well, I'll let you go, and talk to you next time.
Thank you.
All right, Julian. Bye-bye.
Bye.